Today's video will explain the four parts of an integration test. Hello, I'm James Helfrich. There are four types of testing in software. There's a unit test, an integration test, a system test, and an acceptance test. This video will focus on integration test. And integration tests, like a unit test, have four parts: setup, exercise, verify, and teardown. This video will explain those four parts. Like a unit test, an integration test has four parts. The ways these parts are built, however, is quite different than the corresponding parts of a unit test. Now, the first part is the setup. This prepares for the exercise step. Unlike unit tests, integration tests use public interfaces whenever possible. One of the big differences between an integration test and a unit test is an integration test uses the class or method or part of the program in the way that is integrated into the project, whereas a unit test is trying to isolate that function, method, or class from the rest of the project. This is why unit tests access private attributes to directly perform the setup steps, relied upon no other functionality, whereas the integration tests use public interfaces the way that will be used in the application. This means the setup phase of an integration test can be much simpler than a corresponding setup phase in a unit test. The next step is exercise. The exercise step can consist of multiple steps, whereas the unit test exercise is a single function or method call. Now remember, the point of an integration test is to exercise parts of a program as they will be integrated into the main application, which means that we want to call these methods and functions in the way they will be called. In a unit test, only a single function is going to be called in isolation of the rest of the program. But in integration test, we may have multiple function calls, each of which may in turn call other multiple function calls. A single integration test could exercise 100 functions, where a unit test should be only one. The verify step in both an integration test and a unit test is a collection of asserts to verify the program worked the way we expected. Now, it is possible for an integration test to access private attributes or methods, but public interfaces are preferred. In other words, with a unit test, we don't want to call any functions in the verify step. Instead, we want to directly access every private attribute and verify it is what we expect. With an integration test, it's acceptable to use public interfaces to verify the class and function worked as we expected. However, sometimes it might be necessary to directly access attributes to make sure that things work exactly as we want. The teardown step for an integration test is identical to that of a unit test. We want to restore the system back to the state before the test. Most of the time, we can rely upon the classes under test to take care of themselves, in which case a teardown step is empty. But every now and then, we have to return the system state as it was before, such as closing files, severing network connections, freeing memory, or anything else that may have been allocated during the process of the test. To demonstrate how this works, we have a chess game, and specifically this particular class is going to be a pawn, and it's going to check how it moves. So the setup phase is going to use public interfaces in a way that is typical of how the application would use them. The goal is to put the system in a state like how it would be under normal operations. In other words, it's acceptable in a unit test to create an artificial scenario just to specifically isolate a function or method. However, with integration tests, we want it to be authentic. So in this case, I'm going to have the board set itself up using the public interface. Note that a unit test directly accesses attributes in the setup to avoid interactions with other components. They also frequently put the system in a state that would not be in during normal operation. Integration tests are not that way. We're going to use the standard setup here. The exercise step in both the unit test and integration step is to exercise the class or function under test. Now, in an integration test, the setup step can be quite complex. Note that there may be dozens or even hundreds of individual function or method calls in the exercise step. Now observe, I'm going to create 8 individual move objects, each of which is going to have about a half dozen function calls. And then we're going to say board.move, which also will be a half dozen function calls. So there is about 100, maybe 150 function calls in this exercise step. We would never do this with a unit test because we're trying to isolate a single function or method. But with integration tests, we specifically want to see how these different functions and methods work together. Note that unit test only ever calls exactly one function or method. Ideally, this method under test does not call any other function or method beneath it. The verify step for both a unit test and integration test is to make sure the system behaves the way we expect. The verify step may directly access private attributes, may utilize public interfaces, or may even involve other units. Recall that the goal is to involve as many units as possible in a way that they are actually utilized by the system. So in this case, our verify step is going to say position A1, and that's about 2 or 3 function calls. Board square bracket, that's one function call. equals rook, which is another function call. So every line in this assert unit is going to be about 6 or 7 function calls. And I want to make sure that everything is the way it was expected. So there's going to be 8 individual assert units. 8 times 6 is 48 individual function calls just in the verify step by itself. Note that unit tests directly access member variables in the verify step and avoids any or all function calls. Integration tests do not have this constraint. The goal of the teardown step in both the unit test and integration step is to return the system to the state it was before. Now, a unit test does not assume the class in or test has a functional destructor. It is a best practice to explicitly free any reserved memory in the teardown step. Integration tests are not bound by this constraint, meaning that it is far more common for the teardown step of an integration test to be empty. It is best to look at a non-empty teardown step as an indication that the integration test is improperly formed or that a class has an incomplete destructor. You can learn more about the 4 steps of integration test in the integration test chapter of the software design textbook.